So let's say we have this function, x squared plus y squared equals 4. If we want to take the derivative of y with respect to x, or dy over dx, it would be kind of hard because it's hard to isolate y, and there's two y values for every x value. But implicit differentiation allows us to do this easily by just taking the derivative of the full equation. So if we want to take the derivative of the full equation, what we can do is just take the derivative of the left half and set it equal to the derivative of the right half. So if we want to take the derivative of the left half first, we would need to do 2x, because that's the derivative of x squared. But how do we take the derivative of y squared? Well, you can think about it like the chain rule. So you have this function y squared, which is your g of x, and then, well, which is your f of x, and y is your g of x. And according to the chain rule, we can take the derivative of the outer function, ignoring the inner function, so 2y, and then we multiply that by the derivative of the inner function. But we don't know what the derivative of it is yet, so we can just say it's dy over dx, because that's the correct term. Set it equal to the derivative of 4, which is just 0. And now we completed it, but it's not really useful because dy over dx isn't by itself. So what we can do is rewrite it as 2y dy over dx is equal to 2x, or negative 2x, and then this becomes dy over dx is equal to negative x over y. And that's our final answer. So if you want to find the derivative at a certain point, or like the slope at a certain point, instead of just needing the x value, you would need both the x and y values, which makes sense because for every x value, there's two y values. So you can only have one slope. And we can apply the same logic to these types of things. D over dx of 1 over y squared. And if you want to find the derivative of it, we can use implicit differentiation. Now first, let's rewrite 1 over y squared as y to the power of negative 2. And then using implicit differentiation, or kind of like the chain rule, we can rewrite it as negative 2 y negative 3 times dy over dx. And you can rewrite it as 1 over negative 2y to the power of 3 if you want, but this is going to be your final answer. And we can't really set dy over dx equal to anything, and we can't really find it because we don't know what y is. And we're just assuming that y is a function of x, but we don't know exactly what it is. So this is as specific as we can get. Now, let's do some practice problems. If you think you know how to do this one, then pause the video and try it. This one says, find dy over dx if y squared minus x squared equals 8. So first what we need to do is find the derivative of both sides and set them equal to each other. So for the left side and the first term y squared, again, you can just find the derivative of this by treating it like a chain rule, as long as you treat y like a function of x. So 2y, and we're just ignoring the function, times the derivative of the inside, so dy over dx. And the rest is easy, minus 2x equals 0. And now let's try to isolate dy over dx. And we get 2y dy over dx equals 2x. So dy over dx equals x over y. And that's our final answer. Now, let's do another practice problem. If you think you know how to do this one, pause the video and try it. This one says, if y is a function of x, find d over dx of x squared times y. And for this one, we need to use the product rule. So first, let's write x squared times the derivative of y. And the derivative of y is just 1, but we need to write dy over dx because we need to take the derivative of the inside. Dy over dx plus the derivative of x squared times y, so we can write that as 2x times y. And since we have y here, you might think that we need to write dy over dx as well, but we never took the derivative of y, we just decided to write it because of the product rule. So we don't write dy over dx. And this is our final answer. We can't isolate dy over dx because we don't have the set equal to anything, but if we knew what the function y was, we could be a bit more specific, but this is the farthest we can go right now. Now, let's do one last practice problem. If you think you know how to do this one, then pause the video and do it. This one says, find the gradient of the tangent to x plus y cubed equals 4y at y equals 1. And the gradient of the tangent is basically the slope at that point. So first, let's find the derivative of this equation, which means we need to find the derivative of both sides first. So, derivative of the left side, 1 plus 3y squared times the derivative of y with respect to x equals 4 times derivative of y with respect to x. And again, whenever you're taking the derivative of y, you need to think about it like a chain rule. 3y squared times the derivative of y. And then, so now let's try to isolate dy over dx. Or, an easier way is to just plug in 1 for y, as we have no x values in this derivative. So we can just plug in y to solve this even faster. 1 plus 3 dy over dx equals 4 dy over dx. And now we can isolate dy over dx much easier, and we get dy over dx equals 1. And that's our final answer. So 1 is the gradient of the tangent to this equation, which means that's basically the slope at that point. So everything that I explained in this video and all the problems that I went through should teach you everything you need to know about the basics of implicit differentiation. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.